So we've talked about using coordinates to find things in the sky and the kind of stars that you can find in the sky. What I want to move on to is talking a little bit about constellations. And these are patterns of stars that you can see in the sky. So previously we discussed things like the celestial sphere, where we have stars that can be located at all sorts of different distances away from us, but we stick them to a celestial sphere, so they all look like they're at the same distance. If we do that, we can basically trace patterns between the stars. Those stars have no physical relation to one another. The only thing they do is trace out shapes in the sky. So we're literally looking at a join the dots game. So here we've got a star that's traced out by dots 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then back to 1. So a very simple, I'd say boring join the dots game here. And that's really all you're doing with a constellation. You're joining up stars with lines and making them into families so that you can more easily recognize them in the sky and use them as a reference point. So just as a recap, remember the horizon that you're looking at cuts the celestial sphere in half. So if you're in the northern hemisphere or the southern hemisphere, you should only theoretically see half of the sky at any one time. So stars that are above the horizon will move across the sky, and objects will move from east to west. So remember, the sun rises in the east and sets in the west. That'll be the same for the constellations. They'll also do the same thing. If a star never rises or never sets, it's called circumpolar. So just because something's circumpolar doesn't mean it's always present in the sky. If you're in the northern hemisphere, it may be southern circumpolar, which means you'll never see it. So some stars are always above the horizon, some are always below. And this is what we're talking about. So this diagram actually shows a figure of a human here, and this diagram is in the book. Take a look at it. And here's his zenith or zenith. And this star here is moving around as the Earth rotates. And as you can see, it never passes below the horizon. This object, this star does, so does this star, and this star never actually passes above the horizon. So both this star and this star are both circumpolar. This star is never visible to this person, this star is always visible to this person. Now, if this person were to move to the southern hemisphere, they would see this star, the same star as shown here, over here all the time, and they would never see this star. The stars in the middle that we will see from both hemispheres. They will rise and they will set above and below the horizon. So in terms of the constellations, we've defined a couple of these. So the circumpolar constellations are those that remain in the sky all year and never set, or conversely never rise. If we're in the northern hemisphere, typical circumpolar constellations include Ursa Major, Ursa Minor, Draco, Camellia Pardalis, Cepheus, Cassiopeia. Those are all typically northern hemisphere circumpolar constellations that you'll see from our location. Now, there is such a thing as the zodiac, and this is the kind of thing that gets abused in astrology and telling people's fortunes. So constellations and the zodiac that we will actually refer to here are in the astronomical sense. And in that sense, we're saying that these are constellations that the sun passes through on its yearly cycle across the sky. So constellations of the zodiac are those that fall on the ecliptic, which is the apparent path of the sun. And what do I mean by that? Well, this is what I mean. So the Earth is moving around the sun. January 21st, February, March, blah 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 blah, all the way to December, back to January. So this is the Earth's actual position in the orbit. If you were to look at the sun as the Earth moves around in its orbit, the sun will appear to be in different constellations at different times of year. Remember, that's the definition of the ecliptic. So the sun will appear over here in Pisces on March 21st. You're standing over here, you're viewing the sun against the background of Pisces. On May 21st, you're viewing the sun against the background of the constellation Taurus. So the sun appears to move through different constellations at different times of year. And that is what the zodiac really means. They're all constellations that fall onto the ecliptic. They are not anything to do with your future, and they cannot predict what's going to happen to you and if you'll find fortune and love in the next 5 minutes. So the chief point of having constellations was as reference, finding things in the sky. We now have a coordinate system that we can use, and in the modern era, constellation is defined as something a little different that I'll come to. But essentially, constellations are useful for defining where things are. There are also things called asterisms that I will come to, which are not true constellations, but well recognizable parts of constellations. Things like the dippers are actually asterisms and not constellations. But constellations are patterns that are visible in the sky, and we can get those patterns by basically joining the dots. So you're grouping the stars together for identification and a way of navigating around the sky. So a grouping of stars is known as a constellation. And here's such a grouping of stars. You should be able to find this in the night sky in general, even from a relatively light polluted or well lit area. And there's the Dipper. This is the asterism known as the Big Dipper, and it's a particularly useful pattern of stars because this one points to the pole star. So if you need to find the pole star, that's how you do it. So that's why these patterns of stars are useful. So constellations are merely patterns of stars, and the stars in a constellation don't actually have any physical interaction with each other whatsoever. The stars are very far apart, different depths in space, different distances from you. And those patterns of stars have really been observed by people ever since they were on the planet. They've changed somewhat, but they do still have some meaning for us. So ancient people didn't have mechanisms, they didn't have electronics, they had no way of recording time, of figuring out how time was moving on, other than really the day-night cycle. And that doesn't really tell you what time of year it is. If you want to know what the time of year is accurately, saying it was a little colder than yesterday, we must be getting to winter, is not especially helpful. So in terms of constellations, it was a way for people who didn't have a lot of technology to actually tell them what time it was. So as astronomy was used to actually look at what constellations were in the sky, what stars were visible, and to tell you what the time of year was. So this would tell you when it was time to harvest crops, when to plant, what kind of weather patterns would be coming, would it be getting colder, is there a flood every time this year? So a lot of ancient cultures started to develop this kind of mythos, this legend that looking at the stars could really tell you your future. And they believed in its ability to predict future events. So astronomy and the practice, I shall call it, of astrology were very closely linked in their early days. Today, not so much. Very different things. And in the ancient cases, many ancient monarchs, kings, emperors, queens, they had a royal astrologer who was also technically their astronomer to advise them. So for instance, before going into battle, a king may consult his astrologer and say, can I win this battle? And he would look to the stars and tell him the patterns that he saw and what was in the sky and tell him yes or no. Obviously he was just guessing. And in a lot of cases, if he told the king, yes, it will be a wonderful victory, and then he went into battle and everybody was slaughtered, he would often come home and basically execute said astrologer. In the meantime, of course, they lived quite a good life. Modern astrology, what tends to happen is you'll pick up some tabloid newspaper and read page 7 or whatever page it's on, and it'll say, currently Pluto is whizzing through Orion, and this means that next week you will have fame, fortune, and you'll get married and have 12 children and a dog. This is actually not anything to do with science at all. Those people actually just have everything written down on cards for them, and they walk in that week, randomly pick a card, and just print out what they see. So next time you're reading some kind of horoscope and someone tells you that what your future is, please go to an astronomical program, go to a website, go to a book, go and look in the sky and see if Pluto really is whizzing through Orion. Where is Jupiter? What constellation is the Sun actually present in at this moment in time? And you might actually find out that whatever the astrologer said is, well, most of the time, completely wrong. So, I don't hold any faith in astrology, and I don't think people should in general for anything outside of entertainment. So in terms of knowing the difference, here's Galileo, hard-working astronomer, and here's my depiction of an astrologer. I know which one I would trust to do my science. It's this guy. So back to constellations. So constellations were used to tell time. Different constellations are visible at different times of year. Obviously we're talking about the constellations that rise and set, not the circumpolar ones, which are always there. And that timing was crucial to tell people when to plant and when to harvest. A lot of ancient religions also wanted to track time. They wanted to know when it was time to perform certain rituals. And that meant that they would look at the constellations as a calendar system. In fact, a lot of older religions still use a lunar-based calendar and end up with 13 months in the year instead of 12 months in the year. So there's a lot of different time-telling systems that have been used throughout history. And you can look into those for yourself. The modern one is based on the rotation of the Earth around the Sun, which is 365 days, and that tends to be more accurate if you use the constellations as your guide. So in short, there's been a very long history of constellation observations, and because everybody on the planet was seeing these constellations, a lot of different constellations, the actual naming and grouping of objects have been used by different people throughout history. And numerous different names have been applied to the same constellations. So, let's pick on a constellation. Here's Orion. Here's his belt. Here's the sword hanging down. Here's his legs. Here's his body. And here's Betelgeuse over here, the nice big red star. So we use the Greek constellations. So we recognize this as Orion. Well, in the past, the ancient Chinese people just picked on the 3 stars in the belt. And what did they call that? Imaginatively, the 3 stars. We use the Greeks version. So they used Orion, the hunter. And here he is. Here's his sword on his belt, holding an enormous club, and he's recently killed a lion, which is a relatively small lion considering how he's holding it. The Egyptians saw their god Osiris in the sky, the resurrected mummy Osiris. So here's the 3 stars in the belt, here's his legs, very similar in respect to Hercules, and that's not really surprising considering, Orion. That's not really surprising considering that the Greeks learned a lot of things from the Egyptians, including a lot of astronomy. My God. The Hindus saw a goddess riding a peacock. Californian American Indians saw a mountain goat. Not really sure how they made a mountain goat from that pattern, but that's what they did. And the Australians, the Aboriginal Australian inhabitants, the Aboriginal people, saw fishermen in a boat. You can use your imagination and you can draw out that constellation and try and figure out what you would see and basically see what you think of these ideas. Personally, fisherman in a boat, I think is a stretch. So just going briefly through some of the history here, the oldest known division of the sky into 360 degrees and the oldest catalogue of naming objects actually comes from the Sumerians, a pre-Babylonian civilization at 5500 to 4000 BC. So we're going back a long way. And this column that's written here, this stela, is actually written out, and this is their sky catalogue right here. Pretty cracked, not in the best of condition. But the Babylonians put down really the first written evidence that noted periodic changes in the sky at about 1959 BC. And a lot of their tablets actually look at long-term observations of the rising and setting of Venus. Venus was an extremely important constellation to the Babylonians, was Ishtar, one of their gods, and they observed Venus quite heavily. It's also a very bright object, easy to see. But the Babylonian catalogue of constellations was put together at about 1400 BC. And this particular image is just showing us a 687 edition, so quite a modern edition of the Babylonian Sky Atlas, and that contains all the previous research. And here's a written page from that particular volume, and here's their sky map showing some of their constellations with some writing on it. Much of it has been lost. We're looking at pretty ancient archaeology here. So really we can look to people who did a lot of writing, and the Egyptians did a lot of writing, and they observed their own constellations and noted their own figures in the sky. The Egyptian star clocks, had what's referred to as decons or decons, and they had 36 of them. So they had only 36 constellations. And they noted the rise and the setting of those objects, and that's what determined their year length. So they were telling time. And here's one of their sky catalogues. Here's one of their constellations. So we have a guy here who looks like he's taming an alligator while pointing at a bull. And here we have probably the Horus here, and a guy who seems to be inserting himself into this bull, and an alligator getting a piggyback ride from a hippo. So this was the kind of constellations that the Egyptians saw in the sky, the ancient Egyptians. But the accepted Egyptian calendar system was solar-based and not star-based. And the Egyptian star clock was basically 6 hours shorter than the solar clock per year, and that gave them a bit of a mismatch. So every 40 years their solar clock was 10 days ahead of their stellar clock, and this was a serious problem that they didn't really sort out in terms of their calendar. There are a lot of theories about how the pyramids reflect the stars in Orion's belt, and there's a lot of controversy about that, and whether really the Egyptians were trying to draw parts of the sky on the earth in their architecture. If you look at the actual precessional effects and the changing of the constellations, it's coincidental, but you can join up any three objects into a line anywhere. It's possible, but there's a lot of people who have published extensive works on this and probably start joining dots they shouldn't. So be very careful when reading into this, but it is an interesting idea. And there is the Egyptian sky basically carved onto the roof of one of their tombs. And this is the kind of thing you would see in a modern sky program, or if you were to go to a planetarium or look at the sky yourself, but these are their constellations as they would have been. So making things a bit more modern, the Greeks learned a lot of things from ancient Babylon and from the Egyptian scholars, and the Greek constellation patterns remained very similar, where they saw things like Osiris, the Greeks saw Orion. So you often had these patterns made into very similar things. They did, however, rename the constellations from their own mythology. Every society will. If we were to lose all our knowledge and remake these things, we would probably wind up with Darth Vader constellations and Star Wars names. But the Greeks used their own stories. And here's a Greek sky map, and this is the one we use today. Constellation of Aries here is a goat. Here's Andromeda. Here's Orion over here. Here's the Great Bear. So these are the kind of constellations we're looking at. Here's Leo. And basically, during the Renaissance, when science became very important and came to the fore and people started to become more learned, the Renaissance scientists basically learned primarily from ancient Greek sources and texts. So we adopted the Greek naming convention for the stars. And that formed the basis of our modern science of astronomy. And that Greek symbology and naming convention is still used in science today. So here's Pegasus, the winged horse. Cassiopeia, sitting in her chair. Here's Andromeda. And here's a modern view. A little less florid, not as artistic, but here is Orion. This is how we would see it today, with various catalogue values attached to each of these stars and various indicators of the magnitude, being the brightness. So when you're looking at any star map, a larger star indicates a brighter star in the sky. And here we can actually see the Orion Nebula is marked here, and the Horsehead Nebula marked here. The Orion Nebula can be seen actually without telescopes or binoculars. It's better through those, but you can actually see them without. And you can actually see there's Greek letters assigned to each star in the constellation. And that is based on the magnitude of the star in that constellation. And here's our coordinate system. As you can see, this is in hours, this is in degrees, so this is right ascension and declination that we're looking at. So this is a more modern view of a constellation. So a star in an individual constellation is assigned a Greek letter. So you would have, say, Alpha Orionis for the lead star in Orion, and each star in the constellation is then named by position. So here's Ursa Major. Here's your Big Dipper, and you can see Alpha, Beta, Gamma, Delta, Epsilon, and then all these stars are variously named. These M's, these are galaxies. This is the Messier number. This is a galaxy classification system. But there's a lot of things contained in a constellation that are not part of that constellation. So within the constellation of Ursa Major, you can see galaxies. They're not explicitly joined up, and I'll show you what I mean right now. So picking on Ursa Major, the Great Bear, here's the Alpha star, Alpha Yuma, meaning Alpha Ursa Major. Right here is this star. Each constellation into the modern system laid down by the International Astronomical Union has a border now. So this star here, this star, this star, this star, this star, all of these objects here are all located in the constellation of Ursa Major. They don't have to be joined up anymore by a line to be located in that constellation. So modern constellations have a distinct border. And just so you noticed, there's your Big Dipper, located in the constellation of Ursa Major. So, in terms of constellations, we now have 88 official constellations in modern astronomy. That includes the northern and southern hemisphere. So you can't just walk out and see 88 constellations in a night. Modern astronomy uses your Greek naming conventions, and about 50% of the modern constellations are named after characters from Greek mythology. Basically, when people traveled to the southern hemisphere, they took their knowledge with them, and it was really travelers from the northern hemisphere that started to write a lot of things down and rename these constellations. And that means that a lot of the southern hemisphere constellations have more modern names than the northern hemisphere, which are predominantly Greek. So here's just examples of constellations. So here's Pisces, here's Aquarius, the water carrier, Capricorn, the goat, Gemini, Taurus, the bull, Libra, Scorpio, Cancer, Leo. Just so you can get an idea of what these things look like. So your constellation contains more stars than those just joined up by lines. Every constellation set down by the IAU in 1922 has a border, and any star or galaxy or anything else located in that region inside that border is part of that constellation, or is travelling through that constellation. So take a look in the sky. Here we've got Canis Minor, Canis Major, Lepus, Orion, and the Winter Triangle, and all these are individual constellations, individual locations, and they are all broken up by borders, the same way that political borders define a country. So if you put this together and you try to look at this all at once, here we have our celestial sphere looked at from the outside. So here's the Earth at the very center, here's the Sun running across the sky in its yearly cycle, so here's the ecliptic, here's the equator, and here's the constellations located within their individual borders. So it can get a little bit complicated. We have already gone over this. This is just a recap from what we just said. And something I've already mentioned before, but didn't explicitly discuss, was the idea of asterisms. Now, asterisms are small groups of stars that are not official constellations. The Pleiades, the Big and Little Dippers, things that you can find easily in the sky, but aren't necessarily full constellations, but are just part of them. And there's nothing wrong with using them, just so you know that's not the whole constellation. So asterisms are quite acceptable to refer to when you're just looking at the sky, if you want to tell someone where to look. So the Pleiades is a little cluster of stars located in Taurus. Here's Taurus, here's the Pleiades. And they look quite good through basic binoculars or a small telescope. They look like this. They have a nebula to them. They have gas and dust in front of them or to the side of them, and that is scattering the light and giving you this wispy sort of ghostly effect. But the Pleiades is not a constellation, it's located in the constellation of Taurus. So the most famous of these asterisms are basically the Big Dipper, there we go, and the Little Dipper. And these are really located in two constellations which are Ursa Major and Ursa Minor. The Great Bear, there we go, so it forms the middle to tail section of the Great Bear, and the Little Dipper, which forms the middle to tail section of the Little Bear. Personally, I prefer a slightly more aggressive approach to the Great Bear. I just like that cartoon a little better. So as far as constellations are concerned, they do change with time. And there is something called precession. And this is to do with the idea that the Earth's rotational pole is not perfect. So, like when you spin a coin, eventually that coin winds down and the actual pole around which the coin started spinning starts to rotate itself until it slowly falls onto its side. So constellations change with time. The Earth's rotation isn't perfect. The Earth's axis wobbles about a certain central point. So the Earth's pole precesses or spins around one complete circle every 26,000 years. So this is like spinning a top and watching the stick on the top of that rotate around. So every 26,000 years, Earth's rotational pole goes in one complete cycle. And this is what I'm talking about. And this is going to change the way we view our constellations. So here's Polaris, our pole star, and here's our rotational axis, and we're looking at a year here of 2004 AD. Hit play. Well, it's still rotating around the same pole, but the pole is changing position, which means we're viewing different objects at the pole. So you can see now we're at about the year 10,000 AD here, and there we go on a 26,000 year cycle. So our rotational axis in the year 15,000 here is going to be pointed towards Vega. So we'll change our pole star, and the planet keeps on rotating, keeps on rotating, keeps on rotating, and eventually it'll come all the way around. So now we're looking at the year 25,000 AD here, and it'll point towards Polaris again. So that's what I mean by the rotation of the Earth's axis. So just like a spinning top, if you set this spinning, as it starts to wind down slightly, it'll actually precess. The rotational pole itself will start to actually trace out a circle, which means here, if the Earth is doing that as it spins around, it's still rotating about the same axis, but the axis is moving in position. So at one particular point it's towards Polaris, in 15,000 AD it'll be pointed to Vega. So our pole star will actually change. And that means that our current pole star will not always be at the Earth's pole. In 2000 BC, the star Thuban was our pole star. So here's just a larger version of this, just showing you this. And this animation is available in the book, and I'll try and make this available online. And here's the circle that is traced out as our pole actually precesses. So as the pole itself is rotating, it changes which pole star we're looking at. It continues to rotate, and it's coming back to Polaris. There we go. So here's the circle that is traced out as our rotational pole moves around in its own circle. And that has this effect, that here's our constellations that we see very high in the sky, and here is the pattern that will be traced out by our rotational pole. So there's the path of the North Celestial Pole. And as you can see, it's moving through multiple constellations here. So in 9000 BC we were over here. In 2000 BC, Thuban was our pole star. 0 BC to AD 2000, so that's now. Polaris is our pole star. AD 8000, we're getting close to Deneb here, or by the time we come back round again we'll get to Vega. But this is the idea I'm talking about. We'll see different stars located at our pole, but we're talking about a 26,000 year cycle. So this is an effect that we can measure if we're very accurate, but you won't see it in your everyday life. But it does mean that people further back in history saw different stars at the poles. So bear this in mind next time you see people talk about how the Egyptians used the stars to construct their buildings. Those stars may have been in a different position based on the particular effects we've discussed today. So constellations, they're a group of stars, and your constellation can have more than just stars in it. So a constellation, because it has a border, can contain galaxies, nebulae, planetary nebulae, supernovae, things like planets, asteroids, comets, meteors. They will pass through a specific constellation. Just like the sun moves through the constellations of the zodiac, the planets will rotate about the sun the same as we do, and we will see them move through different constellations rather than being a fixed part of a constellation. So keep in mind that our constellations will visibly change over many thousands of years due to effects like precession. There are other motions as well. There is something called proper motion that also changes our positions of the constellation, the stars that make up our constellations. So proper motion is where stars move around the galaxy, and stars are rotating around the center of the galaxy at about 300 kilometers per second, including our star. And that means nearby stars, or stars with really high velocities, are going to move faster than stars that are further away or have lower velocity. So the positions of stars are going to change, and they can change from about 0.001 arc seconds per year to 1 arc second per year. Now, what's an arc second? Well, an arc second is a fraction of a degree. So 1 degree is 60 minutes. 1 minute is 60 seconds, the same as we deal with time. But here we're talking about position. So 1 degree is broken down into smaller units of minutes, and then we break that minute down into smaller units of arc seconds. And we can express how quickly things change in the sky, or positional changes in the sky, in terms of arc seconds when we're looking at very small changes. But remember, we're looking at small changes over very, very long periods. So proper motion will actually have quite an effect. So in the center here is the Big Dipper that we've been picking on for this entire class. And here's all the stars in the Dipper, and I've joined them up with the typical lines that you would have. And those stars are moving, and these lines, these green arrows, these vectors, are telling you which direction these stars are moving in the sky based on proper motion. Now, their annual motions means they'll just rise and set and they'll all stay together. But proper motion, the motion of the stars in the galaxy themselves, is going to actually make them move in different ways. So this star's moving this way, these are moving predominantly this way, and this star's doing its own thing and going this way. That means that 52,000 years ago, this object looked very different. This constellation was kind of misshapen and looked less like a dipper than it did a box on a leash. 100,000 years from now, it actually looks more like a plough or some kind of knife with a long handle than it looks like a dipper. And I would encourage people to take a look at my short and, well, hopefully relatively humorous talk on nitpicking the Battlestar Galactica remake, and look at how proper motion would have affected the constellations that we know and love today.